Hi folks, this is homework number 6, which is to be done or to be shown to the GAs on July 8th. Now, I will not be around on this day. However, the GAs will be on duty between, in the case of morning lab, between 9:30 and 11:20 a.m. to check your work. And for the afternoon lab, it will be between uh, 2:30 and 4:20 p.m. Once again, they will be on duty to help you and check your work. Now, uh, this problem was actually given also last year, and therefore I will not be making a new video for it. However, I will talk to you about what it is, and then after I'm done, after a few minutes, I will attach the solution from last year to this particular problem. Now, it is a problem from another year. Test, I think it was a midterm at that time, but anyway, it gives you an idea of what kind of things are expected, although this marking scheme is not what's going to happen if it was to be given this year. However, at that time, this was the marking scheme. Now, also down here, there are instructions uh, for assigning it last year, which was, of course, everything was online. Therefore, you can completely ignore this marking assignment, this marking scheme. The GA will make sure that you have put an honest effort into it, and you'll give either a 1 or pretty much nothing, and as in the past labs. But some of the statements that are made here are actually going to be helping you if this was to be submitted for online marking, or if it's to be submitted for the final exam. It says here you can ignore these, however, it helps you to prepare for the final exam. Okay, and since it is common to both morning and afternoon, I'm not going to make two separate videos for the two sections. It's all the same. Okay. Now I'm going to stop here and add the solution from last year, or attach it to this particular description. All right. Okay, this is the video solution for homework number 7. The remaining four homework, 7 through 12, are going to be the same for all sections. So notice that on the top it says all sections. This problem is called a 4-bar linkage. So although you see 3 actually bars, there is uh, this one. There is also a fourth one, which is the ground, by the way. I'm not displayed it here. That's why it's called a 4-bar linkage. So OC is called the ground. OA is turning continuously, okay, attached to a motor perhaps. This is the crank. AB is the coupler, okay, and BC, which makes an oscillatory motion in this case, like this, it doesn't go all the way 360 degrees, is called a rocker, okay? Now, mechanism of this kind, which where one link can make a complete revolution, is extremely important because you can attach it to a motor. For example, the wiper mechanism of a car, where one of the things is attached to the motor, and the other one it just rocks back and forth and wipes the window. For the glass is a Grashof mechanism which satisfies or enjoys this condition. Not all mechanisms have this problem. There's some condition which says that the length of the shortest one plus the length of the longest one, this plus that, must be less than or equal to the remaining two uh, linkages. If that's the case, at least uh, one uh, uh, one uh, one of the members makes a complete revolution. Now, you're given some physics here. Okay, this was from an old test, and this is how it was graded. I mean, basically, it gives you an idea of what we consider important at that time. This is how your homework is going to be graded. Though total is out of 10. Of course, in Blackboard, it's reflected divided by 10. It gives you shows you as 1. However, that's how it's graded. And first, you create the mechanism, make sure all the constraints are okay. Then you create the parts that make the constraints. Then you create the mechanism, and then you uh, trace a point. Now, this order, of course, should be reversed. In other words, first you create the mechanism, then you create the trace of the point. Okay, and right, I'll correct this on your homework. And then you plot the velocity versus acceleration of the velocity versus acceleration of the point D in the appropriate unit. That's this part. Okay, and screen capture it, put it in a Word document, and save it, send it to us, submit your work. That's E. And also find a graph which displays the plot of velocity of the point D. Actually, not the velocity, it's the uh, yeah, position of the point D, x position of the point D, because the point D has an x, y, z coordinate, and it changes the x coordinate of the point D as a function of time. Okay, so let's go ahead and do that. Now notice that these bars are nothing special, the 4 of them. So all we have to do is to make sure that the length, distance between these holes is what is given, 10, 26, etc. The thickness of this, the shape of it, it doesn't matter. So I'm going to make a relatively simple one. So first of all, I'm going to save this product, file, save management, save as. Remember, these are all assemblies, so you have to give us the product and you have to give us the parts. So desktop, new folder. Today is July 8. July 8. July 8, and this is homework 7. Okay, so let's put it in there. All right, let us go ahead and make the several parts. So insert new part in there. First, I'm going to make the ground. So let me rename this thing, properties. I'm going to call this thing link. Now let me see. It was OC, OC, and it is the ground. This is the instance name, and this is the part name, OC, ground. So okay, let's make it. Double click on this, make a rectangle. By the way, let me go to the assembly design here. Okay, so I'm going to switch to assembly design. All right, good. Now let's make this. Double click on that. Double click on this ground part so that we go into part design, and on that vertical plane I'm going to sketch a rectangle. Well, actually, you know what I'm going to do? I'm going to make 2 circles here, one like that and another one like this. I'm going to make the distance between them 18 inches. That's the length of the ground. So let me make this thing 18. Okay, and then complete the rectangle. Something like this. So this is going to be the ground length. Okay, move this thing a little bit to the right. All right, so exit, path it, I'm going to pad all of them by 1 inch. Totally irrelevant. Okay, let's go ahead and insert the next thing, which is going to be the crank OA. So on that insert, new part in there. Remember to insert a new part. This is an assembly. You have to create parts. There's going to be 4 parts and 1 product, and all of them have to be submitted. All of them have to be submitted when you do your homework or your test final exam. Properties. I'm going to call this thing OA, and this is going to be the crank. And down here, OA and the crank. Let's make it. So double click on that. You do exact same routine. The only difference is that the distance between the circles is 10. Okay. Make a circle here. They don't have to be the same size because they don't have to be the same size as these. Okay. So distance between this point and that point. First of all, let me make it horizontal for the sake of bookkeeping purposes. Actually, well, I'm going to make it 10. It has to be 10. Okay, fine. Good. Move this thing a little bit. Okay. I'm going to draw my rectangle. This is going to be the crank. All right. Yeah. It just looks nicer if I made this thing horizontal. That's it. Okay. Exit. Add it by 1 inch. Now let's go insert the coupler. Insert a new part. Say no. Right click properties. And that is going to be, I believe it's going to be AB. Right, AB. Coupler. Same thing out here. AB coupler. Okay, let's make it. Double click on that same vertical plane. We will sketch 2 circles. One like this. Too big. Another one like that. The distance between them is 18. Actually, I'm not sure. Check. 26, not 18. 26. 26. Okay. And now we're going to complete the complete the rectangle to make kind of something that looks like that link. Exit. Add it by 1 inch. And finally, the rocker. Go there. No, I haven't saved it for a while, so let me click on the floppy, save everything. All right, so insert the last part, new part, and this is going to be the rocker, which is going to be CB, right? Properties, CB, CB, and this is the rocker. I can do a cut and paste here too. Right click, copy, go down, paste. Okay, let's go make it. Double click on it, on YZ plane with a sketch. Now the distance between those guys is 18, right? This is 18. So a circle, another one. Okay, so it's fine, they're too big. 18 inches. Okay, dimension between this point and that point, this is going to be 18. Okay, let's complete the rectangle. Good. I like this thing better. Exit, parent by 1 inch. Save everything. And now we are in the we use the constraints in order to assemble them. Okay, which one was the rock? I think this was the ground. Let's fix the ground. So here's the anchor. We're going to fix the ground. This was the ground. Okay. Now we're going to put the crank on that. This is the crank. So coincidence. Zoom in between this face. Sorry, this axis and this axis. And if you say update, they will line up. You can see that. Let me just move them apart a little bit. So let's translate this part in the X direction so that I can see something there. Because of the way I made it, those surfaces, those sketches are on the same plane, that happens. Okay, now another coincidence between this axis, the face of that ground and the face of this. Okay. Okay. Update. There we are. Let me rotate this thing a little bit so I can see that. So use the manipulate and rotate about the axis, arbitrary axis. So this is the arbitrary axis. So like this. Very good. This is going to become a revolute chart. Okay. And then I'm going to put, how about putting the rocker there? So coincidence, rocket here. Rocker, not rocket. Coincidence between this axis and not coupler. That's what I meant. Coupler there. Okay, update. This is fine, but except that I want it to be on this side. Okay, that's no problem. So I do another coincidence later on. Coincidence between this face and that face. These arrows tell you whether this is going to end up on the other side or on this side. We'll find out. If it doesn't work, we're going to make this thing opposite. There, obviously I want it to be opposite. Okay, so you go here. The mechanism works. It gives you the correct kinematic information. It's just that it doesn't look good. So say more, opposite, and update. You see that it ends up on this side. Very good. Okay. And now I'm going to put the coupler here, the rocker there. So, well, actually, let's do the coupler first. Coupler and the rocker. Okay, coincidence between the axis of this coupler and the axis of this. Okay, so I want that guy to be on the top. Okay, and update. Let's look at it for a second. Okay, yep, that's good. And then the coincidence between this face and that face. Okay, update. Okay, now what I want to do is I want to bring that hole, and make it coincidence with this. Let's do that first. So coincidence between the axis of this and the axis of that hole, and update. Okay, so this is fine. There's only one thing, and that is notice that it, it ends up in the right spot because I padded these the right amount. In other words, this bottom one is going to convert into a cylindrical joint. If you want, I can also do a face to face, and it's going to become revolute later on. But it is not necessary. So I should have 3 revolutes and 1 cylindrical the way of it. If you had done for the last one face to face, you will get 4 revolutes, which is unnecessary, but that's fine. So save everything. By the way, I think my ground is right here. This must be my ground. Let's check. Let's check which one is the ground. Yeah, that's the ground. So my mechanism actually later on is going to be like this is the ground, this is the crank, here's the coupler, and this is the rocker. Okay, good. So we're good. We saved it. Now we're going to go to DMU Kinematic. So digital markup, DMU Kinematic. And we're going to convert automatically all the joints, all the assembly constraints into joints. So get the magic wand, right? Where is that? Right there. New mechanism. Okay. Mechanism number 1, auto create, so that all the joints are created manually, automatically. Okay. And then let's check. You should have 3 revolutes and 1 cylindrical. Natural degree of freedom is 1, and there is 3 revolutions. Now notice that because we renamed the instances, it tells us exactly what these join. For example, cylindrical join between the ground and the rocker. Remember that last one? I did axis to axis. I did not do the face to face. Okay, good. So now 1 degree of freedom. We're going to take, for example, the one between the crank and the ground, which is this last one, crank and the ground. Double click on it. Make it angle driven, 0 to 360. Because you're going to attach it to a motor. Mechanism can be simulated. Let's check it out first of all with the manual command. This is it. This mechanism is called simulation with commands. That's what I meant. So if you drag the sliding bar, this crank starts to move. Okay, but it does not go 360 degrees. So let's go and check our dimensions, because I have a feeling that our dimensions, we did not do it correctly. So let's go ahead. I noticed, I mean, you can see that it didn't go all the way. So let's go ahead and check that. First of all, we should have had, the ground should have been 18, 10 for the crank, 18, 18, 10, 26, 18. Okay, so let's go ahead. Let's go ahead to our ground. That length should have been 18. Does this 16? Ah, there we are. This should have been 18. Because with what I had, this is no longer a Grashof mechanism. There's no guarantee that any link can turn 360 degrees. Okay, so that should do it. I think the rest of them are probably okay. Good. Now let's update. Let's go to the product. Let's go to the product and update. There we are. Okay. Now let's try simulation with command. This crank should go 360 degrees. Yeah. Now you see what Grashof mechanism, the difference between Grashof and non-Grashof is. Okay, good. So this is fine. Now we're going to do simulation because I want to compile it, get the trace and everything. Mechanism. This is automatic simulation, basically. Make a cartoon. So you drag this thing, all the way, insert, change it to anything but one, rewind and play it continuously. There we are. So as the crank turns, this is what happens. It goes for it. Yeah. If you want to make them uh, go back and forth, it's right there. Now we need this simulation because you need to compile it to get the trace and everything. Okay. Cancel. Let's say reset. Okay. Okay, good. Now remember, I want some information about the point here, which unfortunately I forgot to do to create. So let's go ahead and create that point right at the middle here. So we're going to go back to the coupler. We go back to coupler. We are in part design. Okay. And let me hide this guy. Let me hide that guy. You can see the coupler right in front of your eyes. So we're going to create a point. Create a point, not with coordinate, between 2 points, between 2 points. Okay, point one is, put the cursor here, center of that, right? So I can say, you create a point here, right click, create a point, uh, circle center. So what I'm doing is I'm creating a point here, right at the center of that. Do another one, do another point, point two, right click, create a point, center of that, because I didn't have points there. See, it says create a point between point 2 and point 3 that I just created, and exactly middle point, exactly the middle point. So what happens is that it creates a point exactly at the middle point of those 2 points that I temporarily selected. Say, okay, I have a point here, right there. Okay, let's get these things back to our screen. Get them back here. Very good. Okay, so we're going to go back to the products. In fact, your digital mockup. We created a simulation. It's right there. You can see that. And we're going to compile this. Create a compile a simulation. Okay, so don't use one. Use anything but one. And create a replay. Fine. I don't want a video file. I just want a replay. You need that in order to be able to create the trace. Okay, good. Now here, once you create that, you can go to the trace. Read it carefully. It says element to trace out is this point because I want the trace of this point. Reference product is product 1 and 26 number of points that it creates as a part. So right there, you can see that. That is the path that that point is going to traverse. Right there. Okay. Now, you can save this thing, and let's do that. File, save management, just in case you need it, in case you want to bring it back to the assembly design workbench and put it with the rest of the mechanism. But I'll tell you uh, in a second. There. Let me cancel that. Save as. Okay, fine. Okay, that's fine. Yeah, okay, fine. But for the purpose of this homework, what we are asking you to do is, after you create the trace, right here, I'm going to change these two. Right, because the trace has to be done after you created the mechanism, right, or simulation. you screen capture it. We ask you to screen capture, but that's fine. So there we are. Let me do a screen capture. You can do a cut and paste. Print screen. Where's that print screen? Okay. Start the Word file. Paste it. Now you can prove to us that you know how to create the trace. File, save as. Let me put it in that same folder. July desktop. July 7. Okay, I'm gonna call it trace. I ask you to call it trace. Close that. Now you should have this thing in your obviously folder. Oh, July 7 or July 8? Oh yeah, July 8, homework 7, right there. You can see that. So RGA is going to double click on this thing, see whether it's there, and he knows that you have done that part. Okay, then we are asked to put some physics into the problem, uh, so that the speed of this thing is 60. Oh, I can close this, I don't need it. Okay, we're going to put some physics into this so that the speed of the crank is 360 degrees per second or 60 RPM. So you go to the f of x, click on the mechanism, there is your command, add the formula. So 360 DEG degrees divided by 1s, 1 second, times time. This tells you that the speed is 360 degrees per second. Okay? No messages, everything is, the units are correct on both sides of the equation. And it says, simulated over a 2-second interval here, over a 2-second interval, 2-second interval. Okay, so yeah, simulation with loss, not 10 seconds. Default is 10 seconds, do it over 2 seconds. Okay, now I haven't activated the sensors yet. First, let me make sure that it's working, and then I'm going to create my sensors, the bulb rolling down the ramp, and then plug things. So there we are. There's physics here. That's how it's going to look. All right, good. So rewind or rewind. Okay, good. Close it. Now we're going to create sensors. So a ball rolling down a ramp. There we are. Reference product is okay. So this is, let me call these things uh, okay. So let me call this thing speed acceleration. How about giving it some meaningful name? So I'll call this thing, oops, speed, the first one is, what is it that we want to plot? The first one is x vertex as a function of time. So this one I'm going to call x vertex versus time. Okay, and reference point is right here. This, or reference product is the ground. The point is down here. Okay, and we say okay. And let me do another one. And the other one is uh, Reference product is there. There are different ways of doing this thing and achieving what they ask you, but here's the way I'm going to do that. That's this point. And the name of it, I'm going to call uh, uh, speed and what is that? Acceleration. Acceleration. Okay, good. Okay, so let's do simulation with loss for the first graph. So simulation with loss over a 2-second interval, activate sensor, and that first sensor is just all I wanted to do was X vertex. Okay, X vertex or X of 0.1. Okay, if I selected instead of vertex a point, I did select the point, and this is it. So move this thing out of the way. Did I select? Yeah, right here it says yes. Okay, play it. This is going to generate a graph, which is the X position of the 0.1 versus time. It's going to be 2 seconds, right? Yep. Okay, good. And now we're going to go graph it. Uh, X vertex versus time of 0.1. There's something wrong here. Did I select the right point? What was this point that I selected? This was 0.1. Yes, that's correct. X position. Oh, uh, I actually wanted a different component because of the way I created these things. Okay, maybe I should have asked for the Y component because X component is always 2. This is not lie. It's just that X vertex is always 2, or yeah, for that particular is always 1, right? So I really should have done the different thing instead of this. I wanted, for example, Y. Okay. Um, if you want, you can also get Z. In fact, you can get all 3 of them. But uh, yeah, so you got to be careful here because I don't know how you created your model. It could be that you created it in a different plane and X is changing. But for me, X is not changing. That's fine. Uh, yeah, so you got to be careful. So let's see now. If just to show you what I mean by that, here's X that I selected originally. Here is Y, a different point. Okay, rewind this thing. Rewind this. Clear the history. And I'll play it again. So this time it's going to give you 2 curves. X position, that's not going to change. It's still going to remain as 1, okay? Or 2. Maybe it stays at 2. I think it was 2. But the Y position is going to change because I created my parts in the YZ plane. The X is always fixed. Okay. Actually, I'm going to change your homework so that it says X and Y and Z, all 3 of them, okay? So that you don't run into that problem. Let me see. I'm running into some issues here. This is okay. And Y. And I cleared. Let me do it again. Clear the history. Okay, let's go back. Okay, very good. Rewound. Clear the history. Do it one more time. I'm running into a problem. I want this thing to be faster too, so let me make it 80 instead of 20. Okay, so it's going to go faster. And when you graph it, it should give you 3 graphs. Why is it not giving? Oh, maybe, wait a minute. Why is it not giving me the graphs? Oh, it was hiding back there. Okay, it was hiding back there. Okay, so notice that I asked for 2, I got 2. The original one was the 2 that I really didn't want it. I wanted the Y, and if you do the Z also, it's going to be different. It's going to be different curve. Okay, good. So screen captures this. So print screen. Uh, get a Word document, paste it, save it, save as. Is that the right folder? July 8, desktop, July 8, right there, homework 7. And I will call this thing X and Y because I screwed up. Uh, uh, of vertex. Actually, because I did not pick a vertex, I selected that point. It says 0.1. I'll just remind you, 0.1. Okay. So that's going to be saved there. The GA can see and make sure that you can do it. Now, let me rewind this. Let me remind this and uh, uh, yeah, close that and close this. Do it again so you don't get confused. So click on that one more time. Activate sensor. But the sensor that I want is for that second one, right? So let me undo these. I want the speed and yeah. So this thing actually was not very helpful. Okay, this was not very helpful. So let's do it. Let's do it like this. That one was not. I thought that you could actually get the actual sensor that you created, and no. Oh, wait a minute. Hang in there. Hang in there. So let's see. There must be 2 sensors here. This is one. Yeah. So let me. I was thinking maybe you could select. Let me cancel that, just so that I don't get confused. Let me see if I delete this, what will happen. Okay, because I'm done with that. I'm done with that. So let's go ahead and see. Click on it. Activate sensor. Yeah. So yeah. Okay. Let me select the linear speed. Uh, I did some extra work. There was no reason to create 2 of them. Okay, I could have done it with a single sensor. So let's see now. We want the linear. What does it say? It says linear speed versus linear acceleration. That means the magnitude. Okay, so let's go linear speed. Okay, linear acceleration. Let's make sure linear speed, that is selected right there. See that linear speed selected? Yes, it says yes. Linear acceleration is there, it's also selected. Now you go to options, you create a customized curve, add, we want the linear speed versus linear acceleration. Right there. Right there. Linear speed, linear acceleration. We say okay, and we say close. Where are we going to run it? I'm really sorry about the fact that I created two sensors here. One of them would have been okay, and you could have followed exactly the way I did, okay? It was not necessary to create two separate ones. It got me into trouble. That's fine. That's what we are here for, make trouble. Okay, so this is going to give you the velocity, the graph, which is speed versus acceleration of that point. There we are, okay? So that's what it is. If you look at it, this axis is acceleration, and this axis is speed. Okay, and it is complicated. Okay. Okay. So uh, this screen capture, print screen, another Word document. Paste. There we are. Save it. File. Save as. That was this folder, right? Actually, let's go find it. Right there. This desktop, July 8th. And I'm going to say speed, linear speed versus linear acceleration. All that means is the magnitude, not the specific component. Linear acceleration. Close it. Close these things. Incidentally, if you want to bring that trace that I saved into the part, so insert existing component in there. Okay, it was a trace, right? It was a trace. Bring it in if you want. You're not asking it because you have proven that you can do it by giving us that Word file. Okay? But there we are. And if you actually replay it, you can see that this point goes through that. Okay, so and of course it goes back. You know, in 2 seconds, it starts here, it goes here, and then because this thing changes orientation, it goes back along the same path. So if you click on the replay, you can see that that's how it works. Yeah, that's good. Okay, and notice that if it went further, it'll go back because the sky changes orientation and it goes back. This path is not a closed path. Okay. All right. I'm really sorry about this business of sensor, but we have done several other ones in the class. So I don't know. I created two sensors for two sensors with different names, but I didn't have to. The information that I got could have been done with a single one, and yeah, that's it. Good luck.